Hello YouTube, RJ. Welcome back to part 2 of the LARCSET radio build. We're on step 4, tuning the VFO. It's had me pull out the T5060 torad from the kit, and it's had me take enamel wire, cut 2 foot of it off, double it over through the center like this, so we're starting from the middle. It's a little different than the way I normally start one end with my wire and do it, but you know, everybody has their way. We're staying with the instructions on this in an effort to build it just the way they want it built, see how it performs, built the way they want it. And then after that, we might do a little modification, see if we can do things we want to do. So anyway, we're going to wind this torad now. It wants 30 turns. Each time you go through the middle, that's one count. So we've got a count here already. What you're looking at is be passing through one time, and that's one count. Here's going to be 2. That's 2. This is going to be 3. And then when I'm done with this side, when I've had 15 this way, I'm going to start the other way. Don't overlap them. Try to keep them, fairly close together, but not overlapping. And just keep going. Get you 15 this way, then start with the other side and go 15 the other. So I'll continue on with this, and we'll pick up when we get 15 on here. Okay, I got my 30 turns on my T56 torad. It wants me to cut the wires about 1/2 inch. So let's give ourselves 1/2 inch here. Should be right about there. I'm going to cut it right there and right there. And it wants me to solder the 2 ends of the toroid across the L1. And I'm going to need to do a little scraping here. Let me grab I've got the tool for that. Okay, that's exactly what this tool is for. Let me get some enamel off here. There you go. Don't have to worry about breaking your wire. Get it plenty clean. That's what that's for. Now, let's tin this rascal a little bit. We'll put him in. And then we've got to tune the VFO. So we have a procedure we got to do. I'm going to have to set up for that. So let me get this all tinned up good here. Okay, with that tinned up, we find L1 here. We're going to put him in. Let's see what that looks like. All right, he's soldered in. They want it kind of laid over on the board from what I saw. And what do they want to do? Hook up a small nearby receiver, switch on the LARCSET, tune the receiver across the 80-meter band. You should be able to locate the strong VFR carrier, note the frequency of the VFO. Well, we can do a little better than that. We've got the spectrum analyzer. So let me get rigged up for this. I'll get the spectrum analyzer rigged up, and we'll be able to see what we're getting. Okay, so I'll be right back. Okay, I got the spectrum analyzer set up. I'm going to hook it to ground right here on the board. I went ahead and put her up here. And all the way this way, we're looking at pretty close. Little high, says you can squeeze it together a little bit. I'll get a screenshot of this frequency, and then we'll go this way. And 4.17, so we're better than what they asked for. We're looking really good. Let me put a couple drops of UV resin glue on there and glue that thing down. They want you to use that super glue. It's such a mess. It doesn't stick. So next step is step 5. Crystal filter and the BFO. Crystal filter, it says you have to simply insert and solder the 5 crystals supplied. There they are here. It's advisable you solder them one at a time, snipping the remaining leads of each before proceeding to the next crystal. Okay. And it's clearly marked on the board. It's no challenge at all to find a place to put them. They're all the same, so it doesn't matter where you put them. Not sure why it matters you solder them one at a time and clip them. I mean, it doesn't. I mean, you've got an enormous amount of space between them. It makes no sense that you got to worry about put them in the same direction. Doesn't matter with the crystal, but it's just more professional. Shoot me, I'm not doing what they said. I'm putting them all, I'm going to solder them all at one shot and trim them all at one shot and save time. I can tell you one thing. I'm going to go down and solder one side of each crystal, one side of each crystal, and then go back and start over on the other side. And the reason I'm going to do that is I want to let the crystals cool a little before I hit the other leg. That way, we can keep the peak temperatures down some on the crystal, even though we're not going to be on them very long. That's just a good idea with things that are active, like transistors and crystals and things. Now you tell me, what was wrong with that? Why make a big deal out of doing that? Now I can easily clip all of these off. There's nothing in the way. I don't know why they made a big deal out of it. If they were tight to each other, where you might bridge or get hard to cut or something, that makes sense. But it didn't make a lot of sense to me. Okay, we did that, so we are done with that part. We can move to the next page. And the next page says soldering the trifilar transformers. Okay, now we've got 3 pre-wound trifilar transformers. It's nice they did that. It's a lot harder than winding the toroid like we did before. But we do need to separate these things out and make sure that we have them the right winding to the right winding. It looks like they kind of looks like they've pre-tinned the lines for you. It looks like they've tried to lie it out. They probably have, but I'm gonna have to grab some probes so I can take my own meter. Give me just a minute. Let me grab some probes for the meter and we'll do this and I'll be right back. All right, here we are. Let's see what we got. So these two, those two. So they had nicely separated out for us with this one. I got to make sure I know where I'm putting them. Okay, looks like they used chip layout markings. You can see here they've got some like optocouple 6-pin IC packages. That's where these go. So each one of them that's connected to each other has to go across from each other. So you got to make sure you do that. Could be a little challenging here. Trying to get these wires all in at the same time. A little bit of patience. Take your time. Okay. Ease in. Checking to make sure I got them across from each other. I do. So we're in good shape with that. Let's get that soldered before we do the next one. Okay. Looking good there. Let's get them trimmed. And I'll just do this with two more. Same exact thing. I'll come back. Okay, I got those all on. Board's supposed to look like that. Turn around like that. It kind of looks like that. I'd say that's it. So we've got that done. Now we have to wind two more toroids on yellow T36, T30-6 yellows. So you need to get the yellow ones out here. Looks like we got quite a few toroids. It says you need 1 foot of the enameled wire, so I'll measure up a foot here. Okay. So we're going to repeat what we did before, but with 19. So I'll see you in a little bit. I'll go ahead and get these wound. Okay, I got them made up. Went ahead and stripped the enamel and tinned them as previous on the previous T1. So L1 and L. So L2 and L3 is done. It says install them at the L2 and L3 position. And it says then the radio should look like this. So let's get them in their position. Okay. So let's get these soldered in. Okay. Look all right. Yep. Let's go ahead and trim their leads right off of there. It says install the BNC connector. Our radio portion is almost done. Our receiver portion, I'm sorry, is almost done. So we need the BNC connector before we can switch on the radio. Okay. So let's get her mounted up. We're going to be able to, I guess, receive here in a minute. Transmitter won't be ready, but there we go. All right, RF connector is on. Now we're ready to test receiver. Attach an antenna to it, switch on the radio. You should be drawing around 80 milliamps of current. When you tune around, you may pick up the band activity if there are any active stations. The receiver appears dead. Carefully reheat and resolder through whole components. More often than not, it's a bad solder joint. Hopefully that's not the case with me, but give me a moment. I will get an antenna rigged up here for it, and I will get the audio plugged in, and we'll hook up power, and we'll find out if we can receive anything. So I'll be right back. All right, got everything ready for the receive test. I brought out the bench battery, so I got a quiet power source because powering off that switch mode power supply is not going to be good. I can tell you already, it's going to be way too noisy for it. So I went ahead and we got quiet power here. Of course, everything's on in the lab, so I've got a lot of noise anyway. But we're all way over. Got my antenna hooked up to my wire outside. Should be ready to go. Speakers are turned up. Hopefully, we can hear whatever we hear. So here we go. Static. That's something, right? SSD. Very touchy. Tuning, too touchy. I mean, you breathe on it. Oh, there you go, right? So just turn it on so that the oscillator is going to be warming up, so we probably should give it a minute, try to tune things in. Even. Will you breathe on this thing? That must be FDA. Okay, here we go. Up here.
Okay, I'm not going to touch it. I'll take your word for it. But the only thing I did do is, like I said, I there you go. So you've got your toroid going, you've got the audio much better, leave it alone.
Definitely very touchy. Hardly touch it. I want to do something about that. I'm going to make a change to the radio. That's one of the big changes we're going to make. So, all right, let me go ahead and pause here. And I'll come back for our next steps. Okay, well, it was getting late, so I took a break. I wasn't finding a lot of 40 meter activity when I was trying to demo it for you. And I thought about it after I left and took a break. And so when I come back today, first thing I did was I hooked up my signal gen. I just took a piece of wire, a couple loops, stuck it over here, hooked the ground here, and then I injected about a 5-volt peak to peak 7 megahertz signal with some AM modulation on it. And I tuned around, and I could find it at almost to the dead end of one part of the tuning. So I started adjusting around with my signal generator. What I figured out was I was only getting like the very, very, very bottom, tiny little bit of the 40 meter band, not much at all. I was down to like 6.8 something megahertz. So I did a little work before I went back on cam here. And let me make sure you guys can see this good. The torad for the oscillator, I ended up pulling one in, adding some wire to it, and playing around, and ended up with 2 additional turns. I got a little extra wire hanging there. I'm not going to worry about it, but I ended up with 2 turns. I tried 3, and that was too much. I backed up to 2. That's where the excess here come from. And believe it or not, adding 2 more turns onto that toroid brought me up into the 7 meter band. Don't know why I needed additional windings on my torad, but interestingly enough, forehand states that this radio will cover about 150 kcs of the 40 meter band, and it's supposed to be tuned in the lower end. So basically CW and maybe the very beginnings of the phone part of the band. Well, I want to be able to use the phone band. Just turns out that worked out perfectly, because this thing is tuning in now from just barely off the bottom, like 7.03, all the way up to 7.298, the top of the band. So we're pretty much covering the full band with this thing. So I'm very shocked and surprised at that, but that's what happened with two more windings on the toroid. Again, don't know why mine needed more to be in the right frequency range, but that's where it's at. Checking it when we were assembling it with the spectrum analyzer just didn't seem to do a very good job for me. I'm not sure why, but anyway, we're good. We've got pretty much the whole band coverage now. I was able to tune in some more stations, start picking up a bunch of, phone activity and CW activity and data. So now it's time to finish building this thing. So we're going to go ahead and finish it up and get the transmitter part working. We got some more toroids to do. So we're going to get started on that. Let me get this out of the way. And it says, okay, cut 2 7-inch pieces of wire and wind L6 and L7 with 10 turns each on the black FT3743 toroids. I've got them out. So let me get to that. It's going to be the same exact operation we've done already. I'm not going to make you watch all that. So let me get these wrapped. I'll get them soldered in. I'll be right back. Okay, I got the L7 and L6 put in right here. Markings are kind of hard to notice. They are where they show on the picture, but you just got to really look hard to find the L6 and L7. L7 almost butts right up against the power jack right here. We've got those in. Next, it looks like it wants us to solder Q19, Q13, and PN2222A. Through hole transistors. Their flat side face away from the rear edge of the board. Okay, so they're talking about these transistors right here. So we need to get those out and get them in. And the markings on the board show that, so not that difficult to get them in the right way. So I'm going to drop these in these holes right here. I'm going to solder them in, and I'll be right back with that. And we'll go from there. Okay, I've got the 2 transistors in here, just as they called for. And now it tells me I need to solder the blue bias trimmer on. Got a few bent pins there, going to have to straighten out a little bit. And it goes in right here. If I can get the pins in. Okay, got her in. I'll solder this real quick, be right back. Okay, we got the trimmer put in. That's going to be to control the bias on the transistors. And it says after installing it, should look like this. Yeah, basically looks like that. Power amplifier, step 11. You're going to install the IRF 510 heatsink and the filters inductors. Okay, so it wants me to put the IRF 510 down to the heatsink with the provided screw. So apparently we have a screw in here for this. Okay, doesn't say anything about putting thermal paste of any kind on there, but I'm sure you guys know it's a good idea to do that. It really helps with transferring heat to a heatsink. So he doesn't call for it, but it's getting it. So let me grab a little bit of heat sinking compound. We're going to put just a tiny bit on there. Spread it around a little. It's awful messy. So that will help it conduct a little heat more effectively. Should be firmly tight for proper conduction. Grab a better screwdriver for this probably. All right, that should work. Okay, doesn't want you over tighten. We didn't over tighten. Did say we're installing it, but after putting the heatsink on, it says nothing. So, but it did say we were installing it. So let's get it installed. I'm gonna solder this in real quick. Looks fine. Let's trim her off. Okay, now our PA transistor is mounted. Now we've got L4 and L5. They have different values, so it wants you to do one at a time. So let's get these toroids out. One's going to have 17, one's going to have 19. So I'm going to go ahead and do those up. I'll be right back. Be the same way we've done all the others. Okay, I got the first one done. 17 turns. It tells me to put it into L4. And I ran into a problem. It says insert the inductor in L5. This is the inductor footprint towards the edge of the board. Okay, well, I found them down here. And this one's marked L4 or 5. This one here has inductor 4 marked over it. But this says L4 or L5 is the one close to the edge of the board. Which is it, the marking on the board or this? I don't know what to go by. I went by the markings on the board, but I don't know if that's right. These are the kind of things, instructions that need to get fixed. Very aggravating. I'm going to take a minute off camera, go do research, look at the schematic, figure out which is really which so that I can get it right. And I'll be back. Okay, I just got off the internet, found on Group.io, I found a bunch of people talking about this transceiver kit. And yes, the manual's correct. The board is marked incorrectly, so don't go by the board. I'm going to have to swap this inductor over to a different location. So I'll get it out and move it. So let me get the desolder warmed up, pop that out, move it, get the other toroid made, inductor made and dropped in. I'll be back with you. Okay, I've got those inductors installed. So L4 and L5 are now installed properly. And yes, L5, which is your 17 turn toroid, goes to the back against the back edge right here. So that's L5. This is L4. Markings on the board are kind of hidden, but you can kind of see them. They're wrong. They're absolutely backwards. Now that we've got that done, that completes the assembly of the radio, it says. So now we have to set the PA bias, the power amplifier. So we need to get hooked up with a dummy load. Need the microphone plugged in. We need to adjust the bias, press the PT, adjust it to get a standing current increase. All right, give me a few minutes to get what I need set up on the bench for this, clean up a little bit and do that, and I'll be back and we'll set the bias. Okay, I've got all set up to do the PA biasing. I've attached the dummy load as requested. I've got my microphone, my 3D printed home built microphone from my other home built radios that I made set up and hooked up. I've got the trim pot turned all the way clockwise. I need to power this thing on. I'm seeing about, I've got the virtual O1 meter set up there so you can see the current pulled. I'm pulling about 100 milliamps. It says press the BTT. I should see 170 milliamps around. Okay, as you can see, I'm seeing a little over 200 milliamps. I'm a little high there. Turn the pot anti-clockwise until I get to 350. So we're going to push down, be quiet, and we're going to turn this up to 350. If it's typical, I'm going to turn away without making any difference, and all of a sudden I'll start changing quick. So you have to be easy and take your time with this because all of a sudden it's going to shoot up. You don't want to pop the finals by over driving them with bias. So here we go. Okay. Okay, we're getting 350 just as it says. So, okay, we've turned it. We've got it 350. 12.6 says speak clearly in the mic, elongating your vowels to increase the average power of the transmitter. This DC current draw should increase to about 0.6 amps. Okay, let's see. Audio, 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 audio. I'm not seeing any increase at all. Audio, audio, audio. Well, I think we're going to have some troubleshooting apparently on our hands. I know this mic is hooked up properly. So I think this is probably, it's too much to get into troubleshooting. I think it's a good point to stop this video, part 2. The radio is built. Obviously, I've got an issue here. We'll pick up in part 3. We'll troubleshoot and figure out why we're not getting modulation and get this thing working. And then probably like maybe part 4 might be us modding this radio to make it far superior. So, hey, thanks for hanging in here with me on this project, and appreciate a like if you can take just a moment to click the button. I would appreciate it. If you didn't like the video, click dislike. That's okay too. But most of all, I hope to see you in the next video.